Good afternoon. This is video 3 of our Lathe 3-part programming session. So far we've gotten the robot to pick up our part, place it into our lathe machine, then move over to the table. So the final thing we're going to do in here is we're going to create the table program, and then we're going to create the for loops to do this over and over again. So let's see what we have so far. Let's hit play and run our program in our master lathe program, which is the program in which everything is being called upon, and we're trying to make that as streamlined as possible. And here's where we're at. So we had to move that around just because we're pretty close to the machine. We probably can get away with moving the robot a little bit further away, but for the sake of this, we're just moving the robot out of the way, or the position. So now let's create our program. So the first program we called upon was the pick up the lathe part, and the drop off the actual part is very similar to that one. So what we're going to do is we're going to copy it and we're going to modify it. So let's go to the program listing and let's go to lathe part pickup and let's enter on that just to make sure that's the program. This is the program, so let's go back to select and we're going to copy this. So let's arrow over, go copy, and let's arrow over to the end and we're going to pick up and we're going to go place instead of pick up. And now we are going to go down for our place, enter inside that, and let's modify a few things. The first thing, we do not want to go to the home position because it is over here. We want to stay in this position that we moved from our previous program. So we're going to get rid of these two lines. So we're going to edit command and we're going to delete. Make sure that our teach pendant is on. So now that we're at that position, now we're going to switch our position registers to number 4. So that's the place position with the tool offset that stays the same, and also the offsets for the in feed right now, we got to switch it to the out feed. So the out feed was 11. So let's go out feed 11. So let's do the same thing here. So 4 is going to be our position, and we are going to do an offset of 11. And then here's going to be our pickup simulation. So we're actually going to switch this to place simulation. And then we're going to call the place. So right now it says blank pickup. So let's go choice. And then this is going to be part drop off. So finish part drop off, arrow down, continue on. And this is going to be number 4 for our place position. And position register 14 for our tool offset is good, and then tool for our offset is going to be number 11. Moving on down. So now it's asking to go to the home position, but if we go to the home position, most likely we're actually going to run into our part. So let's go to these positions and see what happens when we do the home position. So I'm doing a step mode, calling this drop off. Here's our safe position, and then here's our home position. So you can see, looks like we came very close to hitting our part. So we may have to do a few between, make sure that everything's good. So let's go here back to this position. And so I moved to the position, I added a few lines to the home position here. And what I'm going to do is I'm going to just kind of get this robot in the position of having the joint. So this is where you would actually use the teach pendant. Where I want it to be, and then I'm going to add move point, and I'm going to do a continuous joint movement from that position over, and then we start rotating this around, making sure that I'm not going to hit my lathe at move point. And we're going to do another joint movement all the way over to here, in which it'll go back to the home position. So I'm going to add move point, continuous. And now we're going to go to that point there. So now we have a movement path in which we know that it's not going to hit our lathe back to the home position. But this is where if you create a home position that has a smart or sniffing out where you're at in degrees, and knowing that you have a lathe here and maybe an obstacle here or a person there, you may be able to create a home position program that knows, okay, I'm at this angle, I'm going to move via this path. So now let's put this lathe part place onto our main program, master program. And we're going to place. And then let's call upon that program. Start place. All right, let's see how this runs. Moves out of the way, back to home position, and now we're ready to rock and roll with the next part. Now there was some extra movements in there, and that probably has to do with the rotation of our part here and the direction in which it is. We placed it on the table. We wanted to make sure that the UCSs of them match so that we didn't do a bunch of rotations like you saw on our actual robot. Alright, so now that we have everything programmed, now we can go in here and actually program the loops so that it runs through everything. So inside of our master program, we're going to go right between after the variables. So when we reset our variables, this is when the actual programming starts. So we're going to add some lines in here, and we're going to be doing 2 for loops, one for the columns and rows, and we can actually do both of these in feeds and out feeds at the same time. We don't have to do multiple loops. I did set up some variables just in case we needed to. We could probably delete them now. Doing it this way. Again, there's multiple ways of doing things, and however you want to do it, if you do it differently, is completely up to you. So it's the variables. We're going to add a couple lines here. So let's go ECM, insert, and let's insert, say, 4 lines. First, let's turn on the actual teach pendant. Always do that. And then let's head this. And we're going to call this loop. So the first loop we're going to do is the for loop. I always like to use a for loop because then I don't have to do a counter or a jump label. It does everything for us. So we're going to go for and for loop. And we're going to utilize register number 3, which is our column start that we did as our data register. So data 3, column start. So this is going to be our column, which is the culminating item. So inside of our column, we have 1, 2, 3, 4, just like we have on the outfeed table. So we're going to go between 1 and 4. So it starts out with 1, and then it goes 2, 3, and 4. So inclusive on 4. So it includes 1 and inclusive on 4. Then inside of our column, we're going to have picking from each row. So we're going to go new instruction, and we're going to do another for loop, 4, and then this is going to be our rows, which is going to be register number 4. There's our row start. And just like our columns, we have 4 of those as well. So we're going to go between 1 and 4. So now that we have our for loop, the first thing it's going to go to is the column start. As soon as we go into the column start, then we move right into our row start, and it does all 4 inside that row. Then it moves out of that row and then into the column, in which it goes to column 2. Then it does all the rows. So we have 2 for loops, one nested in the other one. So let's move all the way down to the end of the program where we have our finished part, and now we're going to add our additions to our registers so we can do the offset. So let's do new instruction, miscellaneous, and we're going to go remark, and this is where we're going to change the row variables. Changing row variables. So inside the row, we're going to be changing because how the robot is. So if you look at this is our x-axis. So the x-axis is actually the columns and the y-axis is the rows. We're going to pick from our first part, which is the lower left here, and we're going to go in the positive y direction. Then we're going to place also in the positive y direction as well. So we're going to do both the in-feed table and out-feed table, which is the position register number 10 and position register number 11. So let's go new instruction, registers, and we're going to add to that register. So we're going to go position register IJ number 10, which is our in-feed table, so offsets in-feed, and we're going to change the Y component, which is number 2. We're going to set that equal to our position register IJ, which is number 10, and Y component, which is 2, and we're going to add 150 to that. That is the spacing between our parts in which we created. So now we need to do that for our outfeed table as well. So we can either do that again or we can copy this. I choose to copy. Copy, and then paste logic. And then we're going to go 11 for this. And that's going to be our outfeed table. So we're doing the infeed table and outfeed table. We're swapping both of them at the same time. So now we're going to have our end 4 after this. So we changed our number, so we're moving over 150, 150 4 times. So we're going to go new instruction over end 4. So this is our first for loop. So that is the row for loop. Now we need to change the column items, and inside the column items, let's add a few rows. We are going to set the row offsets back to 0, and then we're going to move up in the column area. So let's set the offsets first. So let's go remark, and we're going to go changing row and column variables. So the first thing we need to do is reset our row variables. So let's go new instruction, registers equal to position register ij, and we're going to go number 10, and the y component, we're going to set that back to 0. And then we're going to go registers ij, and this is going to be 11, the y component, and we're also going to set that back to 0, because then we're going to add 150, 150, 150 again. So then after that, we're going to now move up in our column direction, which is the x direction. So the x direction for this way is going to be positive, but our outfeed table is going to be negative. So we have to pay attention which direction we need to go. So we're going to go new instruction, registers, and we're going to plus equal to register ij, and this is going to be 10, which is our infeed table. The x component is equal to our position register ij 10 and our x component, and we're going to add 150. Then we need to do that for our x component on our outfeed table. So we're going to go new instruction, registers, and we're going to subtract this time because we want to go backwards. Register ij, and this is going to be 11. The x component, position register 11, x component minus 150. And now we can end that for loop. Instruction, and then end 4. And let's get rid of some of these lines that we have left. There we go. So now we have everything set up. Let's run the program, and I can probably see something that's going to go wrong, and I noticed that when we were testing things. We'll say that we did this on purpose just to show a problem that may arise. But if you look at what our robot has right now, the faceplate is facing forward, and if we go to our motion here, show joint movement, notice how we can't go all the way around here on our joint movement. That's going to be a problem with our outfeed table because we won't be able to reach that. So what's probably going to happen once we get to this portion right here is the robot's going to actually rotate all the way around to this position down here. So to fix that, I'm actually going to move the table closer to the lathe so that we are able to do that. But in actual retrospect, we should have had this base plate facing the actual lathe and have the tables on each end. So that's a mess up that I did, and kind of an oversight that I did as well. Now we could change it and modify it, but we would have to change a few points, whereas if I move the table over, I would just have to change one position register, and because we're offsetting everything, that's all we have to change. So it's very easy to do for that. But let's actually run this so you can see what it looks like, and then we'll see if the robot actually goes around. So there we go. So it just rotated all the way around so it can reach these last two parts. So what I'm going to do is I'm going to just move this over and then into the proper place, and then we'll reset the position register, and then everything else should be fine. So I'm going to just pause the video and move things over, and then I'll show you how to change the position register right away. It's very easy to do. Alright, so I moved it, and I moved it pretty close to the machine, which hopefully is not going to be a problem. But again, this is most likely we would change the programming around to have the plate so that's facing the machine, so that it has the full swing from left to right and also forward. So again, that was an oversight on my behalf, my bad. So let's move to this position here. So we double click the plate, and then let's move to part 1-1 and then go move to, and now we're into that position and it's exactly where it needs to be. So let's go to data and find the place position right here, and then we go shift record, and then it resets our recording, and that's all we have to do. So you can move this table to wherever you want, and all you have to do is record that position so that all the offsets based on that. That's why we use offsets, because then you don't have to retrain a bunch of different places, because everything is based off of a single point. And if you know that single point and you save that single point, then it makes things easy. So let's run through, and in the video I'm going to actually speed it up to probably about 3 or 4 times speed so that it's not a 30-minute video like some of them are. So let's actually run through this. That's our last part. So that's programming. Again, I apologize for the outfeed oversight, but again, pretty simple to fix if you're just watching the videos from start to finish. You can do, and you can rotate things around and then just reteach some of the points. So everything is based off of just a few points and then just a bunch of offsets.